Hi everyone, welcome to yet another session on AI/ML for the product leaders. In today's session, we are going to talk about the journey that every enterprise has to go through. The journey will talk about the shift from the classical machine learning model deployments to enterprise ready model serving. What does it mean? We'll be talking about how we can do the movement to product readiness, talking about the strategic scaling, and also the execution maturity that need to come along the path when we are going to deploy the machine learning model to be production ready. We'll be talking about the different aspects in detail. So let's hop on to the discussion. So here as we see, in today's talk, we'll be exploring what happens when a model goes from working to working at scale. We'll talk about what breaks, how to fix it, and why the right inference engine, be it RACER or LLM, can be a difference between a demo and a dependable AI product. Here, here I have broken down this journey into three phases. First one, we'll be talking about the POC, that's proof of concept with the Flask API. So we'll be getting the model live with Flask, followed by MVP on taking a call on the hitting the and will be hitting the bottlenecks and will be deciding to pivot to inference engine primarily. Then we'll be talking about the production, that's phase 3, wherein we'll be moving to vLLM or RACER and will be scaling reliably. So let's begin. So the phase 1, in the beginning, the goal is very clear. We need to validate fast, prove the feasibility, and show the value. At this point, simplicity is our best friend. We take a trained model, maybe XGBoost, maybe a classification model, and we wrap it using a Flask API. It's quick, it's light, and it allows us to expose a predictable endpoint, or you can say a prediction endpoint in a few minutes. Here's what this stage helps us to prove. It will prove us the technical feasibility, business value potential, and stakeholder alignment. If we talk about technical feasibility, we'll be able to answer these questions. Can the algorithm handle real world data? Are we getting reasonable accuracy benchmarks? And can we integrate the model into a simple service? If we talk about business value potential, the business value potential would give an answer to the following questions. Means, does the solution align with the business objectives that our company hold? Do we see a visible return of investment here? And can we justify the further investment for the product? And also, it will help us for the stakeholder alignment. A POC is also a sort of communication tool because this will help us build internal confidence, strengthens the sponsor buy-in, and ensures that everyone aligned on why this problem actually matters. So before we move to the MVP stage, we need to understand what's the success criteria for us for a POC, or in what prospect we can call POC a success if we are able to give answer to the following. First of all, does it work? Does it matter? And should we invest more? We need to have all these three answers to be yes. Then only we can move forward. But this is actually where the reality will begin to hit us. Because when we move to phase 2, these are the basically the aspects that we just talked about, the feasibility and the challenge identification beforehand, by stakeholder buying, so we all will be on the same page, and then business value potential. Now when we move to the phase second that I iterated, it's more like an MVP stage. It's a tipping point. The MVP stage is where most machine learning teams will feel growing pains because the Flask is amazing when we intend to give demo, but it breaks when the real traffic arrives. Where Flask starts failing? What are the blockers for Flask basically? It's the throughput drops because Flask is single-threaded by nature. When hundreds of inference requests hits per second, Flask just cannot keep up. Latency increases. Why? Because requests queue up, prediction goes slow down, and the user experience become unreliable. Memory pressure also increases. Heavy the machine learning models, especially the embedding or the transfer model, starts consuming a lot of RAM and or the GPU memory. Also, there is no batching. So if we just see here the Flask limitation also that we are just talking about, we see as we already discussed about it, talk about single threaded and lack of batching because Flask serve the request one by one, which is disastrous when we did a parallel inference. And also the operational overhead skyrockets because you see the teams start fighting with threads and load balancers, scaling, and also patchwork solution comes into picture. And what makes this a critical decision point? Because here the leadership plays a very big role because business leaders usually need to understand why is it slow, why can't we scale this to more customer, why do we need new infrastructure. The honest answer is quite simple here because Flask is not built for production machine learning workloads. So this stage forces us to strategically think about the architecture, the scalability, the cost, and indeed the long-term maintainability. And this call leads us to the phase 3. So primarily, if we talk about the limitation we saw, we'll just reiterate. It's more like increasing the latency, the memory issue, and also the concurrency because it's not able to keep up with the increasing number of requests per second. So throughput is low. So eventually that leads us to the change in architecture, wherein we need to understand what would be our solution that will serve our machine learning model to be production ready. We have an option. It could be vLLM or Racer. Both are the frameworks to address this throughput issue that we have just seen with the Flask. So we talk about what exactly comes in picture with the production grade inference. So the production grade inference is something that we can achieve by using vLLM or Racer. So we need to understand where model becomes a product. This is the stage where we can call a model to turn out to be a product because the real production workload demands high throughput, low latency, batching, GPU utilization should be good, should be reliable, observability, and also the cost efficiency. And moreover, multi-model composition also comes into picture. And since Flask cannot do that, inference engine can. And then this is something where we are able to attain the above said requirements by using inference engine. So if we talk about VLLM is basically an extremely powerful inference engine. That is because it solves the biggest bottleneck of LLM inference, means the memory fragmentation and the KV cache inefficiency. And how VLLM is a game changer here because it helps us to attain the ultra high throughput using paged attention mechanism and continuous patching. Let's talk about all the three aspects one by one. The first one is the paged attention, that's a KV cache virtualization. Means instead of allocating the massive block of continuous memory, vLLM uses the pagination system. It's basically how operating system virtual memory works because it helps us to reduce GPU fragmentation up to as good as 80% and also helps us to enable long context windows and dramatically speeds up the inference, means the response for the user query in the real time. Also, it has continuous batching because requests need not wait. New requests can join the ongoing batch and hence it massively boosts the throughput. As good as 24 times higher throughput we can attain by using against the traditional Flask or Hugging Face pipelines. And since battery is the memory usage, so we need to have fewer GPUs and hence lower cloud cost. So along with the vLLM, we have an offering for using RaceHub that itself has its pros and cons when compared to vLLM. For the sake of the this discussion, will not be deep diving into RaceHub, but we can highlight okay, RaceHub is also one of the options that we can leverage. But continuing this discussion to vLLM, we'll hop onto the decision framework. So when we talk about the decision framework, we need to understand certain things. We need to understand what all we need in this whole evaluation process. We need to we are able to make a decision on what tool exactly we need to use. We need to use Flask for POC validation. Using quick iteration, we can do it fast. vLLM is something that we eventually need for high throughput and efficient inference in a real time for the production deployment. And just to sum up the strategic decision path would be like to start with Flask, do the evaluation until the Flask limits hit, then we can move it to production ready using the framework, be it vLLM or RaceHub. However, if we quickly compare the different three different stages, so when to choose what? So basically, if you say at the stage of POC, we go for Flask because rapid validation. We go for MVP. At MVP level, we can go for a limited scale. MVP can be done with Flask, but once it hits the limit, throughput goes down. Then we have to go for LLM based, which is vLLM inference engine. And for production, we never recommend using Flask because it's not something production ready. However, for high throughput, we eventually need to go for vLLM. So from the leadership lens, if you say why this journey matters, basically is we see we are able to get the strategic foresight. We are not just training models, but we are planning how to scale them responsibly. We are able to get the cost optimization because we understand inference engines reduces GPU cost as good as 80% and has direct borderline impact. Reliability and trust also increase because customer doesn't see if customer doesn't see your model accuracy, they see latency now and they see uptime and stability. And tooling maturity is also one of the aspect because we are able to choose the right inference framework that saves months of work, and go to market is also accelerated here because we are doing faster deployment, faster iteration, and eventually faster value realization. So this is what we had on agenda for today. So if we just see just to summarize, the major key takeaway for us is like Flask help us to validate fast. MVP highlights the scaling challenges when the Flask starts hitting the limits, and then vLLM or RaceHub, either of these two inference engine for illustration we have taken, turn out to be the model, turn out to be the game changer that will turn the model into the real product. And using using this demo and the what aspects we have talked about, we can say an organization can master these transitions to understand how we can scale the AI solution efficiently, perform consistently, and generate the meaningful business impact. Thanks for being there. This was what we intended to cover for today. Thanks.